margin or that? Even if you don't measure this, you should be pretty close. How long is your third side? 13 centimeters. You can even measure it and see that it's 13, but of course it's more accurate, especially since we can't draw this perfect. If this was perfect measurements, then this would be exactly 13 centimeters, according to the Pythagorean theorem. You need to identify A, B, and C. I'm going to use angle A is going to be my smallest angle. Angle B will be my next bigger angle. And angle C is always your right angle across from the hypotenuse. And for angle A, what is this side right here? For angle A. What's this side for angle A?
The 23.
No. What side is this?
Oh, that's
For angle A. Adjacent. You need to know how to label these. And this one is opposite, and this is the hypotenuse. It doesn't matter which one you're talking about. For angle A, you need to write the sine of A, the cosine of A, and the tangent of A. These are ratios based on what angle you're looking at. You have opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. Substitute your values in. You're looking at 5 over 12. 5 over 13, excuse me. 12 over 13, and 5 over 12. And you can get decimals for these. Find your decimals, write them out, find your angle based on those decimals. You can look them up on your chart, or you can use your calculator. One thing I like about these is that the degree, whether you're in radians, degrees, or gradients, it's right here. It's listed right there. It's got to have a little DEG that tells me it's in degrees. It makes it a lot easier because those calculators don't say that. You have to actually go to mode to see if you're in degrees or not. That's why I kind of like these calculators. They're easier to use in some ways. 5 divided by 13 is 0.3846. And what you need to do, all you need is one of these. You don't really need all three. If you wanted to use just sine, you could still find the angle, couldn't you? Because all you have to do is look under sine and look up 0.3846 approximately. And that's between what two angles? Where does 0.38 fall in for sine?
22 and 23.
Between 22 and 23. So A is approximately 22.5. If you use the cosine, you'll notice that 0.92 is also between 22 and 23. So is the tangent. You only have to have one of those ratios to find your angle. For angle B, the only difference is these two are switched, aren't they? The sine, this is the sine of B, isn't it? And this one is the cosine of B?
Yes.
And those two switch. Because this is not the adjacent, this is the opposite for B, and this is the adjacent for B. That's the only real change.
And the pattern is
Yeah, it's the inverse. If you do the reciprocal or turn it over, you get the tangent, which is approximately the tangent of B. 2.4 something?
No.
2.4 exactly? Yeah. Good to go? Now, if you're given sides of a triangle, a right triangle, you can use whatever ratio you're looking at to find the angles. If you're given just two sides, that's all you really need. And on your worksheet, that's what they're asking you to do. On some of the questions, they're asking you to find the ratios. On some of them, they're asking you to find the angles. Take a look at 7.6. What you should do the odds for 7.6, and then for extra credit, you can do the evens. But you must finish the odds in class. You have about, almost an hour. So off time. So you're going to do worksheet 7.6, the odd exercises. Evens are extra credit. Use your trig ratios on the table if you want.
Whatever food. What? No.
You all should have drawn a right triangle. One leg was 16. Rico, you're already done with this? Why not? No. You're supposed to do this. You're supposed to draw a triangle. It's not that complicated. Draw a right triangle. Measure your angle to make sure that it's actually a right triangle that you're looking at. Two legs. 12 and 16. This should be a right angle. 16 centimeters. 12 centimeters. And hypotenuse. You were supposed to label your sides. This is always C. This is the vertex. This is a vertex, and it's across from the smaller side, so I'm going to call it A. The one across from the larger leg, I'm going to call B. You should have already done this. You should label this side. What side is this? Depends on which one you're talking about. This is side B because it's across from angle of B. But depending on which angle you're looking at, it can be the opposite or the adjacent. This one is side A, and this is side C, and you're supposed to use Pythagorean theorem to find side C, which is 20 centimeters long. And this is, something that you did in 5th grade. Everyone should know these are legs. This is a hypotenuse. You should choose one of your angles. I'm going to choose angle A to start with, and I wanted you to find sine of A, cosine of A, and tangent of A. These are fractions. Sine is found by taking opposite over hypotenuse. Cosine is adjacent over hypotenuse. And opposite over adjacent. You have to label your sides based. So, no. A, angle A. What is this side for angle A? For angle A, what is this side? Opposite. Opposite. It's a cross. This one is adjacent, and this one is hypotenuse. This is always the hypotenuse. It's the longest side. You were supposed to write your fractions. This isn't a difficult thing to do. You were supposed to write opposite, which is how big? 12 over the hypotenuse, which is 20, and you were supposed to change that to a decimal. That's it. Now there is something else that we're going to do today which is a little different. I want you to think about how to do this. I want you to look at the chart, the trig chart that I gave you, and you'll notice that it has a bunch of decimals for different angles. I want you to figure out what angle has a sine of 0.6. Look it up. What angle has a sine of 0.6? 37. Or it's between two. 38. No, 41. What? 41. 41. Oh, yeah. No. Try again. You're looking at sine. You're looking for 0.6. 37. It's close to 37. What else is it close to? 36. It's in between those, isn't it?
Yeah.
Look, guys. Under sine. If you look under sine and you look at 36 degrees and 37 degrees, you're going to find 0.5, what is it, 87, isn't it? Oh, 78, and 0.6018. And 0.6000 is between these two. 0.6000, right here, sine of A is right here, 0.6000. So what's the angle for A? Between these two, what's between those two? 36.5 degrees, approximately. That isn't exact, but it's close. Try it with your protractor and see if it's close to 36.5 degrees. Should be. Mine is at 37. Should be somewhere around 36, 37, right in there.
130. 41.
35. Okay. Measure it very carefully. And it should work. Got it?
I got 36.
Okay. If you look under cosine, you're going to find that 0.8 is right in the middle, isn't it? And if you look under tangent, you're going to find that 0.75 is right in the middle of these two, between 36 and 37 degrees. The point is, it doesn't matter which one of those ratios you use. You can use any ratio you want to find your angle. You can look up sine, you can look up cosine, you can look up tangent, find your angle. Do the same thing for B. The difference being that for angle B, this is now opposite, and this is now the adjacent. Find sine, cosine, and tangent for B, and then look it up. What's the sine of B? .8. And the cosine of B, 0.6. You've reversed the sine and the cosine for the two angles. We already know what it is. Since A is 36.5, we already know what angle B is, but I still want you to try it. Find angle B. By the way, cosine of A is going to be 16 over 20, which is 0.8. Tangent of A is 12 over 16, which is 1.75. If you want to put in the extra zeros, you can. Well, of course. It has to be between 36 and 37 degrees. All of these are the same angle.
Totally